Okay, here comes the second video, exam 2, section B. Let's have a look. So now if we consider this function, we want to express f of x in the form. So let's define the function first. I think I'll be getting x to the power 3 take away 2x squared plus 8 divided by 2 lots of 4 minus x squared. Notice this form is actually, a proper fraction form rather than a partial fraction form. So I do prop frac f of x. And notice this form here is not exactly the same as this one, so I'll write that as 2x over 4 minus x squared. And the equation of the straight line asymptotes, it will be x equals to plus or minus 2, and also y equals to this linear function. And then we can find the derivative. Okay, so that's pretty much the first part. And then we want to state the coordinates of any turning point and also find the point of inflection, stationary point of inflection. What I'll do is zeros, y minus f of x, comma, derivative, comma, xy. So I'll get 3 pairs of coordinates. The first one will be 2 square root of 3 minus bracket is 3 root 3 minus 2 in the bracket divided by 2, 0, 1, and also negative root 3, 2 plus 3 root 3 divided by 2. I suppose that's the 3 exact pairs of our coordinates. And the point of inflection, if you quickly plot the f of x, you would see there is a stationary point of inflection at 0, 1. And then we would like to draw the graphs. Notice that there's a oblique asymptote, which is minus half x plus 1. So that's the first thing I'm gonna draw. Okay. I think I just get let's say that make sure you use ruler. Okay. Also, I'll draw x equals to minus 2, x equals to 2. And I know there is a stationary point of inflection, 0, 1. The graph roughly cuts through, minus 1 point something. The question wants you to write the x-intercept with any values correct to 1 decimal place. Therefore, I'll just go for analyze graph, 0. Yeah, this is the x-intercept, minus 1.5098. So that I'll write as minus 1.5, comma 0. This is part of the graph. You can see every time when I do the graph sketching, especially math course, I'm taking extra care, right? Taking extra care. So actually, say something like that. Okay. Probably I can draw this one slightly thicker. Okay, try not to touch the asymptote, right? And also, you will need to draw the two branches. Actually, I'll just tidy that up a little bit. Okay, something like that, right? And also notice the point of the stationary points, like a maximum. I think these should be 2 root 3, but it's at a 3.46, which is roughly 3.5, and a minus 1.59, minus 1.6 something. Therefore, I would say a point would be here, okay? And from previous working, I should get, let's say, 2 minus 2 root 3 divided by 2, okay? Because the question didn't say you label that correct to, some decimal place. So still write that as, an exact pair of coordinates, right? Something along this line. Actually, it should be here, okay? And then the other point is roughly here. That's minus 3.5, roughly speaking, and 3.6. So I believe it's somewhere here. I just put an arrow here, and that's minus 2 root 3. And then this should be 2 plus 2 root 3. Actually, 3 root 3. Have to be very careful. So this is 3 root 3. 3 root 3 divided by 2. So that's another branch. Okay? Make sure you demonstrate, let's say, the correct behavior, okay? On these slides. Yep. Try your best. Use pencil. Okay. If you consider, this graph here, fk of x, divided by 2 over k minus x squared, for what values of k will the graph of fk have only one straight line asymptote? Because this is a cubic divided by a quadratic. You actually get a linear and plus some fraction. Then, if you don't want any, vertical asymptote, there must always be, an oblique asymptote, which is a linear function, y equals to mx plus c. Therefore, what I can say is, if k minus x squared equal to 0 has no solution, this would be x squared equals to k, means it's less than 0. Therefore, I'll say k is less than 0. And then, if you think about this function here, you want to find the oblique asymptote and find the values of b for the graph to have only two straight line asymptotes. So say fb of x is x to the power 3 plus b times x squared plus 8 divided by 2 times 4 minus x squared. So I'll use prop frac again. So now you can see there is another, oblique asymptote. Y equals to minus x divided by 2 minus b over 2. And If you want to find the values of b to have two straight line asymptotes, you could also use expand this time with respect to x. So now, what I'll say is fb of x is b on two lots of x plus 2 minus b plus 4 divided by 2 over x minus 2 minus half x minus half b. Therefore, if b equals to 0, we only have x equals to 2 and y equals to minus half x. If b equals to minus 4, we only have x equals to minus 2 and y equals to minus half x plus 2. Therefore, pretty much, it's these two values, okay? So this question is done. And then we can move on and have a look at the next question. Okay, circle in the complex plane, 0, 0 is 3 plus 4i. So this is the center, z0 equals to 3 plus 4i. Radius of 2, so we go to the right by 2 units, left by 2 units, up 2 units, down 2 units. So eventually we'll get a circle. Something along this line, okay? And this circle, we will have a point v equals to 4 plus iy, where y is greater than 4. So I think this will be my point v, okay? And point w is the reflection of point v in the line imaginary z equals to 4. So I think imaginary z equals to 4 is this guy here. And this will be, w, okay? Yep, of course. Sketch the circle, draw the line, and also label the 3 points. Then to find imaginary v, which is my y here, we could think about, let's say, the equation z minus 3 plus 4i equals to 2, something along this line. One possible approach is you write x minus 3 squared plus y minus 4, whole thing squared, equals to 2 squared. And also, the real v equals to, 4, okay? And basically, the v is like a complex number z, so you could also write, for example, real z equals to 4. That means your x is equal to 4. So you can solve these two equations simultaneously. For example, you can either do a solve command, x minus 3 squared plus y minus 4 squared equals to 4, comma x equals to 4, comma xy, given that y is larger than 0. So you actually get, let's say, actually y larger than 4 rather than larger than 0. You only get, let's say, this is root 3 plus 4, okay? So you can actually label this one as 4 plus root 3 plus 4 I, and this one will be 4 plus 4 minus root 3 I, because I think this distance here must be, root 3. This distance must also be root 3, and these two, will be the reference point of this perpendicular bisector, okay? Solve simultaneously for y greater than 4. X equals to 4, y equals to root 3 plus 4. To answer the question, I will address imaginary v equals to root 3 plus 4. The next thing is we find the area of the major segment bounded by an arc of the circle and a chord connecting v and w. So basically, if you think about, let's say, the previous diagram, we've got, let's say, this point is 3, this point is 4, x values. So this will be a 1, and this will be root 3. Therefore, you will get, let's say, 60 degrees, and also another 60 degrees. So the outer angle, theta, the rest, will be 2 pi minus 2 lots of pi over 3. That's 4 pi over 3. In order to find, let's say, the major segment, I'm still using the same area formula. Half times 2 squared, r squared, times the angle in radian measure, subtracting sine, the angle in radian measure. And then you can just do that minus that. So that's the final answer. You could also use integration though, but I don't think it's necessary. In this case, you just use the trig measuration, circle measuration formula. All right, the tangent to the circle at a point V and W intersect at a point P on the line y equals to 4. Show that the x-coordinate of P is 7. I think there are many possible methods, but one possible method I would use is, for example, at a V, this point is going to be, 4, 4 plus root 3. This is the center. I think it's a 4, 3, I suppose. Oh, actually, sorry, 3. Yeah, 3, 4. So basically, yeah, this is one possible tangent. And notice this is a perpendicular tangent to the radius. Okay, so now if you say this is 60 degrees, this is 30 degrees, you know this is like xp, 4, because that's a given condition. What you could say is, by perpendicular tangent and a radius, see the diagram. We can use right angle trigonometry. Say, this is a radius of 2, isn't it? And then this distance here is xp minus 3. We could have sine 30 degrees equals to 2 divided by xp take away 3, the horizontal distance, the difference between the two x coordinates. So xp minus 3 is going to be 4 because sine 30 degrees is half. And then you will get xp equals to 7, right? So that's one possible approach. Alternatively, you might want to, let's say, find the equation of this tangent and the other tangent and solve them simultaneously to get the x coordinate is 7. But I think just for 1 mark, you probably just need to, let's say, some sort of a suitable argument with some reasoning and working. There are 2 circles that passes through point P that are tangent to the circle and have their centers on the line y equals to 4. Find the equation of each circle in the form z minus zc equals to r, where zc represents the center of each respective circle. So what I'll do is, if I draw a circle like that, I probably would mark, let's say this point is 1, 4. This point would be, let's say, 3, 4. And this point would be 5, 4, right? That's one possibility. Then, if you like, let's say, one circle to pass through point P. Where is point P? So basically, Point P is over there, 7/4. A possible circle to be tangent to another circle, I'll draw that in red. May look like this, actually. See, this is one possible circle. You can have, let's say, the center over there between 5 and 7. So this will be 6,4. And the radius is going to be 1. Equation 1, you will have z minus 6 plus 4i equals to 1. Okay? And the other possible circle, well, between 7 and 1, if I want this one to be my diameter, you could have, let's say, something like this, right? See what happens? It's the larger circle, and I think the center is going to be, 7 plus 1 divided by 2, that's 4. Therefore, the center is going to be here, and the radius is going to be 3 units, okay? So you could have z minus 4 plus 4i equals to 3, okay? So these are the two possibilities. Therefore, drawing some useful diagrams as accurate as possible will be very helpful in this sort of question. And actually, this is a lovely complex number question, not that hard. Only 9 marks. Let's move on. Actually, 9 marks, 10 marks, 10 marks, 10 marks, 10 marks. Did we have 11 marks for part 1? Oh yeah, question 1 was 11 marks because I'm thinking about the total number of marks. Okay, question 3. Chain rule. dy dx is dy dt times dt dx. dt dx is the reciprocal of dx dt, so that's just 1. dy dt, I think that's just y plus 1 times y. Yeah, y plus 1. The question wants you to use integration and show that it's this guy. So notice that dx dt equals to 1, giving x equals to t, all right? And yeah, it satisfies x naught equals to naught. So the integration constant will be 0. What happens is now, if x equals to 0, y also equals to 0 for the same t value. What I'll do is dy over dx equals to y plus 1. Then 1 over y plus 1 dy equals to dx. So you actually get log e of, bracket y plus 1 equals to x plus c. I mean, I know a lot of you would need to add absolute value here. However, based on the initial condition, y not equals to naught, when checking that, it's log e1, which is a positive argument anyway. So just get, let's say, a positive version here, and rearranging, we will get, let's say, y plus 1 equals to ec times ex. And I will make this one the format a times e to the power x. And then subbing y equals to 0 and x equals to 0, this would lead to 1 equals to a e to the power 0. So a equals to 1. Therefore, y plus 1 equals to 1 times, ex. And eventually y just equal to ex minus 1. Okay? The graph of that between 0 and log ek for x for constant k greater than 1 is rotated about the x-axis to form a solid of revolution. So, I mean, if you draw a quick diagram, suppose it's that part. rotated about the x-axis. If the volume of this solid is pi times log k, use calculus to show that k satisfies this equation, hence find the value of k. We can actually do part 2, because if you factorize the given result is k minus 3, k minus 1 equal to 0, but k must be larger than 1, therefore k can only be 3, okay? Because you can cross out the other option. But in terms of, let's say, the volume formula here, firstly, it's pi integral from 0 natural log k. And we've got y squared, which is ex minus 1 squared. I'll write pi 0 to natural log k, e2x minus 2ex plus 1 dx, something along this line. So I'll clearly show, let's say, the integration process. Evaluated from 0 to natural log k. And that will give us, let's say, a half. Well, when x equals to, natural log k, it implies ex equals to k. So this guy will be half k squared minus 2k plus natural log k. That's one thing. Subtracting a half e to the power 0 minus 2e to the power 0 plus 0. So that will be pi half k squared minus 2k plus natural log k. And this will be subtracting a negative 3 over 2. So we add a 3 over 2. Okay. And that is pi times half k squared minus 2k plus 3 over 2. Notice you can split out the pi natural log k, isn't it? So when v equals to pi times half k squared minus 2k plus 3 over 2, add pi times natural log k equals to pi natural log k. You can cancel these two terms. That's 0. You get a pi times, half k squared minus 2k plus 3 over 2 equal to 0. So you actually get a half k squared minus 2k plus 3 over 2 equal to 0. And that's why you get a k squared minus 4k add 3 equals to 0. Quite a bit working for 2 marks, but the question said use calculus to show that k satisfies this equation. So I believe the expectation is to show the construction of the definite integral and how you obtain a correct antiderivative. Once you get a correct antiderivative, show the work equating to, let's say, the k expression to pi log ek and do the cancellation leading to the correct answer. Okay, express the length of the curve in the form of, a definite integral in terms of t. So actually, I'll start from an arc length formula. This is x1 to x2. 1 plus dy dx, whole thing squared, dx. This will give us 0 to natural log 5 square root 1 plus ex, whole thing squared, dx. Also, from previous part, we knew that x equals to t. So dx over dt equals to 1, and dt equals to dx. Therefore, the two x values can be equated to the t value. No need to change. So we just get 1 plus e to the power 2t and dt. Notice that this given form had a dt after, so don't drop your dx or dt along the way. And find the length of this curve. Give your answer correct to 1 decimal place. Because for this particular case, you just have, let's say, x in terms of t, the same thing. Therefore, you can use, let's say, this command. Exponential x minus 1 from 0 to natural log 5. So you can get a direct answer, or you can just do integral square root 1 plus exponential 2t, t 0 to natural log 5. It's the same thing, right? So L equals to 4.367, etc. Rounded to 4.4 units. All right. Curve given by this thing between 0 and log E5 is rotated about the y-axis. So it's a good idea to, tracking, let's say, x value. So when x equals to 0, y is e to the power 0 minus 1, that's 0. When x equals to natural log of 5, y is like 5 minus 1, that's 4. In this case, I prefer working with, Cartesian form. So the surface area is 2 pi integration from y equals to 0 to y equals to 4. We have x times square root 1 plus dx dy, whole thing square dy, and 2 pi from 0 to 4. What's my x? It's just a log e y plus 1 square root 1 plus 1 over 1 plus y, because dy dx is y plus 1. So reciprocate this guy, you get, let's say, 1 over 1 plus y dy. And we have find the area of this surface, so we have 2 pi. Shift plus 0 to 4, natural log y plus 1, square root 1 plus 1 over y plus 1, whole thing square, dy. That's the answer. If you use, let's say, the parametric form, I think this is doable. Parametric form, basically, if you use s equals to 2 pi from t value equals to x, so it's still 0 to natural log 5, and then your x is going to be 1 times, let's say, actually, nah. Yeah, x is, sorry, this should be t rather than 1, because x equals to t. And then you could get, for example, this is 1 square dx dt squared plus, yes, y plus 1. You could get, yeah, dy dt is y plus 1, which means this is going to be e to the power t. Y equals to e to the power t minus 1. So dy dt is going to be e to the power t. So you actually get e to the power t squared dt. Let's double check with this form. 2 pi shift plus 0 natural log 5 t times square root of 1 plus exponential 2t dt. Good, same answer. This is another possible form, right? But it has to be completely in terms of t and dt. If it's correct. Okay, right. Vector function. We have a drone here, another drone. Now it's interesting to see them using, d1 of t, this sort of notation. So anyway, I just do, let's say, for instance, I would be using, for example, d1 of t is 2t plus 1, 3t plus 1, 5t. d2 of t is 5t, 10t plus 2, and 3t plus 10. Speed of drone 1, we just take the derivative. d1 of t, you can see it's 2, 3, 5, and then you take the magnitude of velocity. This is the speed, okay? So v1 of t is 2i plus 3j plus 5k. Speed equals to magnitude v1 of t. I think it's 4 plus 9, 13 plus 25, 38, rounded to 6.1644 kilometers per hour, which is rounded to 6.2 kilometers per hour. And then find the angle between d1t, d2t at t equals to 2. Okay, so d1 of 2 equals to 5i plus 7j plus 10k. d2 of 2 is 10i plus 22j plus 16k. Therefore, the angle between them, cosine theta equals to d1 of 2 dot product d2 of 2 divided by the multiplied two magnitudes dot p d1 of 2 comma d2 of 2 divided by norm d1 of 2 norm d2 of 2, and then we take the arc cos of this value, convert it to the decimal degrees. Yeah. So this question is cast driven, very cast driven. So theta equals to 17.8 degrees, correct to 1 decimal place. Yeah, pretty much the standard type of, vector questions you could ever expect on any specialist math exam. Okay, shortest distance between drone 1 and drone 2. So basically we say, all right, let L of t equals to magnitude of d1t minus d2t. It has to be, the displacement first. Then we take the magnitude of this displacement. Norm d1 of t minus d2 of t. So this gives 2 bracket 31t squared minus 16t plus 51 under the square root. And then to minimize this function, we take L dash t equal to 0, or use F minimum actually. So t equals to 8 over 31, and we round the time in hours correct to 3 decimal places. So let's say this is 0.258 hours. And L of minimum equals to L, but I'll still sub in the exact value for the best accuracy. So let's say that given t equals to 8 over 31, we get square root 94054 divided by 31, which is rounded to 9.893 kilometers. Alternatively, you might want to, complete the square, but it's within the square root, comma t. So you actually get, let's say, the shortest distance. When this thing is 0, you take the shortest distance, square root of that value, it's exactly the same thing, okay? So that's an alternative approach. Okay, you have, let's say, drone 3 and drone 4. Define them, t1t, t plus 1, 2, t plus 1, relative to the same original displacement measured in kilometers, time measured in hours. So if you define d3 of t to t1t, d4 of t is t plus 1, comma 2, t plus 1. And then cross product d3 of t, d4 of t. This will give you, let's say, 1 minus t I plus 0j plus t minus 1 k. It's a vector quantity. And when t equals to 1, you would see all components will be 0. So d3 times d4 when t equals to 1. Actually, I would say d3 of 1 times d4 of 1 is going to be 0i plus 0j plus 0k. If the cross product between two vectors are giving you 0 vector, that means the two vectors must be parallel to each other. And then, in terms of the specific locations, what I'll do is I'll put a 1 here, and a 1 here. See? 1, 1, 1, and a 2, 2, 2. Therefore, the positions lie on the same line, originating from 0, 0, 0. Okay? So you can see the ratio 1, 1, 1, 2, 2, 2. And you can get a line from, the origin. Okay? Because the question wanted you to explain what this result means in terms of the locations of drone 3 and drone 4. All right. And at the time t equals to half, drone 4 begins to malfunction. So the position vector is now this function, d4t. Using this new position vector, determine the values of t. Values of t when the two drones have the same speed. So in this case, I assume t is larger than or equal to half, or t is larger than half. The next thing is I'll redefine d4. Because there is no more part of this question. T plus 1 sine t plus cos t, and also t plus 1. Then I'll just do norm of shift minus t, d4 of t equals to norm derivative of the strong 3, okay? So you get some equation like that. d4 dash t equals to this, actually, I'll use capital D instead. Capital D 3 t dash. So that actually gives you square root of 3 minus 2 sine t cos t equals to square root of 2. And what I'll do is I can solve this equation for all possible t. So you get, let's say, t equals to 4n plus 1 bracket pi over 4. Notice that because t is larger than or equal to half. So if you try, n equals to naught. This is 0.78. This is the first time when the speeds are equal to each other. So n value has to be 0 plus union 0. Okay? So we take n equals to 0, 1, 2, 3, 4, blah, blah, blah. Okay? So that's done. Even if you use, let's say, your by hand calculation strategy, I think this question is not awfully challenging. Its idea is very simple. Just take the derivative to find the velocities and take the magnitude of velocity and equate the speed. Question 5. 3-point P1, P2, P3 using the vector method. Okay. The key here is to use a vector method rather than, cosine rule, sine rule, whatever. So anything valid method related to vector should be acceptable, I say. So P1 is actually 4 on 3, 4 on 3, and 0. P2 is 4 on 3, 0, 4 on 3. P3 is 0 to 2. So now I want to find the two spanning vector rather than, taking the cross product between, just the position vectors. For example, I will say U is assigned to P2 minus P1. And then V is, let me try P3 minus P1. Or you could do P2 minus P3, it doesn't really matter. And then to find the area of a triangle, we just need to find the cross product, U and V. And then we take the magnitude of the cross product divided by 2. And that's the answer, okay? But make sure you clearly define your two spanning vectors, okay? So write down the two vectors. If you notice the multiple later, the ratio of I, J, K components will be 2 lots of negative 16 over 9, 1 lot of negative 16 over 9, 1 lot of negative 16 over 9. So the ratio is 2, 1, 1, okay? Can be useful later. So area of triangle is half magnitude of U cross B. So that'll be 8 root 6 over 9, okay? So that's one possible method. If you say, okay, how about, half AB sine C? Well, it's doable. So for example, if you do dot product of unit vector U, unit vector V, this will give you cosine theta. So I'll do the other method here. Let theta be the angle between U and V. So you could say cosine theta equals to U hat times V hat. Because once you take the unit vector, the other side is just U hat magnitude times V hat magnitude. That will be ones, okay? So that will be, cosine theta is going to be root 7 over 7, something along this line. And then you can say area of triangle is half U magnitude, V magnitude, sine of cos inverse of root 7 over 7. Not sure if it's completely vector method, but I computed, let's say, the angle, the cosine of the angle using, a vector method. So if you use norm U, norm V, arc cos, sine of arc cos, and then you just divide it by 2. So that's 8 root 6 over 9, okay? Alternatively, you could use, let's say, the perpendicular resolute and find the magnitude as a height. Then use the, a spanning vector as the base, half base times height. But look, I think use a vector method, you have many options. And then a normal vector from part A is n equals to 2i plus j plus k. All right. And now the Cartesian equation is 2x plus y plus z equals to some sort of alpha, right? Okay, so to find this alpha, we need to solve, let's say, a point. I would say this is the easiest option. For example, I could say 0 plus 2 is 4. Don't forget to state the final answer. Therefore, 2x plus y plus z equals to 4. Oh, fairly a standard question. And then, if we move on, another plane with equation 2x minus y plus z is 6. Show that the plane is given by, this expression. This, this equation will give a plane pi 3 parallel to pi 2. Okay, so you can rearrange this expression, can't you? So what I'll do is multiply all terms by 6. This will give you 2 lots of d minus 1.5z equals to 6x minus 3y. So that will actually give you 6 minus 3y equals to 2d minus 3z. Therefore, you get a 6x minus 3y plus 3z equals to 2d. Now, in order to match the coefficient, you can divide everything by 3, so you get a 2x minus y plus z equals to 2d over 3, which has n3 equals to 2I minus j plus k. That is equal to the normal vector of equation pi 2, all right? Then you want to determine the values of these so that the minimum distance between pi 2 and plane pi 3 is 2 root 6. Well, distance pi 2, pi 3 is the magnitude of, look at this part here. This is the right-hand side coefficient with 2 minus 1, 1, 2 minus 1, 1, and 6. We can just do 2d over 3, the constant term subtracting another constant term divided by the square root of 2 square plus minus 1 square plus 1 square equals to 2 root 6. Therefore, you get a 2d over 3 minus 6 equals to 2 root 6 times root 6. That's 12. Therefore, you get a 2d over 3 minus 6 equals to plus or minus 12. Okay? And a 2d over 3 equals to either, 18 or, let's say, minus 6, I suppose. So you can actually solve that easily. Then 2d equals to 54, or 2d equals to minus 18. Therefore, d equals to 27, or d equals to minus 9. You can solve that easily by CAS. Yep, these two answers. Find the possible values of P for which the two planes are perpendicular. So N2 equals to 2I minus j plus k, and N4 equals to P square I minus P plus 2j minus 5k. If they are perpendicular, we will have N2 times N4 dot multiply equals to 0. We can actually create a dot product equation. 2 minus 1, 1, P squared minus P plus 2, comma, minus 5 equal to 0. So we can solve that equation for P, and then you get minus 3 over 2 over 1, okay? Yep. That's pretty much everything. And then we can move on and have a look at, oh, finally, last question. In preparation for an upcoming competition, the snowboarder undertakes many descents down a competition slope. The times taken for the snowboarder to descend the slope may be assumed to be normally distributed with mean 200 seconds and a standard deviation 5 seconds. So say x is a normal distribution, 205 squared. Time taken for any one descent is independent of the time taken for any other descent. Find the probability that the times taken for two descents differ by less than 5. So d equals to x1 minus x2, which follows a normal distribution. This is going to be 0 because the expected value of d will be 200 minus 200, that's 0, but the variance of d is going to be variance of x1 plus minus 1 square variance of x2. So that's 2 lots of 25, which gives you 50. Therefore, I would say the standard deviation of the difference variable is square root 50. If it's differing by less than 5, you could have, let's say, the difference is between minus 5 and a 5 because you never know which one is larger. So you can actually use normal distribution. Minus 5 to 5, 0, square root of 50. So the final answer is 0.5205. 4 decimal places. Find the probability that the average time of 4 descents, so this is talking about a distribution, x bar 4, normal distribution. This time is one single variable, the average, so it's 200, and the variance will be sigma squared divided by n, which is 4. And now, if it differs by less than 5 seconds from the mean, this is the mean value 200, differ by 5, that would be 195 backwards, or 205 forward, okay? So it's two-sided. Therefore, I would like, let's say, the x bar to lie between 195 and 205. So I can actually get a norm CDF 195, 205, 200 square are actually square root of 25 over 4. So actually you get a lovely number, 0.954499, which is like a 2 standard deviation away from the mean, okay? Rounded to 0.9545, okay, for decimal places. Okay. Use the following information to answer part C and part E. To try to improve descent times, the snowboarder applies a new Teflon-based wax to the snowboard. To check the effectiveness of the new wax, the snowboarder makes 25 descents of the slope and find the mean time taken is 198.5 seconds. To assess the significance of this result, a one-sided test is performed at a 5% level significance. So assume that a previous standard deviation of 5 seconds still applies. So we're comparing this 198.5 with the previous mean value. Therefore, the null hypothesis, we still say, all right, no significant change. No significant improvement. So this is my null hypothesis. And H1 is mu is less than the previous expected value. So have significant improvement. Basically, the logic is if we have the evidence to reject H0, that means we have significant improvement. If we don't have enough evidence to reject that, we can conclude no significant improvement. So that's a logic. So the p-value can be carried out, can be calculated by statistics, stat test, z-test. Use stats. Okay, mu naught is 200, sigma is 5, x bar is 198.5. 198.5, and m value is 25. This time I'm using mu less than mu naught. Press OK, Control Enter. So the p-value is probability x bar less than or equal to 198.5 given mu equals to 200, where x bar is normal distribution, like 200, 5 squared divided by 25, something along this line. For decimal places, we say 0.0668, okay? And does the application of the new wax produce a significant improvement at a 5 level of significance? Here, my p-value is larger than 0.05. No sufficient evidence to reject H naught. Because we can't reject H naught, no significant improvement is concluded. Therefore, no significant improvement. So the answer is no, it doesn't. Okay? So you need to address the question more than just say reject H naught or don't reject H naught, because this time they actually ask you a yes or no question. Okay? And you have to link this back to the meaning of H naught and Hy. Okay, the wax manufacturer claims that the descent times will be reduced by at least 2 with the application of the new wax, assuming the mean descent time of 200 seconds is in fact reduced by 2%. So this time, mu1 equals to 200 times 0.98. That'll be 196. What the question is asking for, find the probability that the snowboarder on the basis of the 25 independent descents will conclude that the wax is ineffective. So we say, all right, assume a standard deviation of 5 seconds. This is arriving at, don't reject H naught, but based on, an incorrect side, okay? So this was 200, the old mean value. This is the actual mean value, 196. Basically, previously we had a significance level of, say, this is my alpha, 0.05. And then we somehow need to figure out this beta, okay? So in order to figure out, let's say, the probability of beta, which is the type 2 error, we firstly need to find a critical level, okay? A critical level. Say the critical level will satisfy probability of x bar less than or equal to c star. Given mu equals to 200, that is 0.05. And my c star can be found to be 198.355, 1464. Then to find the beta equals to probability of x bar greater than or equal to c star. But this time it's under, the actual mean 169. Okay? So you can use norm CDF that value to infinity. 196, 5 over square root of 25. So actually you get a very much smaller value. But you only round that to 2 decimal places, so it's only up to these hundreds. Therefore, I'll get a 0.01. Okay, you can see it's a significantly small value. By the way, when I was attempting this question, I actually get so used to these sort of questions. Therefore, you might want to try the following approach. I know this year, toward the end of this year, we still don't need to use the press to test mode, but for 2027, we haven't received any official announcement or further specifications as to what functionalities will be banned on the CAS calculator. But I can do solve system of equations, and in this case, I just want a C and maybe a B. B refers to beta. So B value equals to norm CDF C to infinity, comma, 196, 5 divided by square root of 25, or you can just type 5, and norm CDF minus infinity to C, 200, and maybe 5 divided by square root of 25 is 1 equals to 0.05. And I can apply a domain restriction C is greater than 0. Control Enter. We can actually solve for the critical value and also the type 2 error probability in one line of calculation. But anyway, yep, this is pretty much everything I need to work through for this recent NHT Specialist Maths Exam 2, together with my analysis to the multi-choice questions. Hopefully you will get prepared towards the end of the year, the November Specialist Maths exam as well. All right, that's my solution. Everything here. All the best. See you next time.